Hi friends, this is Raja. Welcome to Coder's Companion. The topic that I am going to cover in this video is Bitwise Operators. This is a series of videos on Python programming for beginners. And for more videos, you can visit my channel or click on my playlist link given in the description. Before moving on to the video, I would recommend you to subscribe my channel so that you get the notification each time I publish a new video. Let's get started. This is the fourth topic in Python operators. Bitwise operators act on binary digits and perform bit-by-bit operation. Listed here are the bitwise operators with examples. Let's understand each one in detail. Before going further, I wrote down the numbers 0 to 10 and their binary equivalent. You can get binary representation of any number using bin function. These are some examples. Bitwise AND operator. Bitwise AND means to perform AND operation bit by bit on the operands. For bitwise AND, ampersand symbol is used. Let's understand bitwise AND operator with an example. Here I created two variables, x is equal to 4 and y is equal to 6. On performing bitwise AND operation, x ampersand y, the output is 4. Let's analyze how we got the output as 4. The binary equivalent of 4 is 100 and the binary equivalent of 6 is 110. Now I am performing AND operation bit by bit. Output of 0 and 0 is equal to 0. Output of 0 and 1 is equal to 0. Output of 1 and 1 is equal to 1. So the output is 100, which is equal to 4. Bitwise OR operator. Bitwise OR means to perform OR operation bit by bit on the operands. For bitwise OR, pipe symbol is used. Here the variable x is equal to 4 and y is equal to 6. On performing bitwise OR operation, x pipe symbol y, the output is 6. Let's analyze how we got the output as 6. Now I am performing OR operation bit by bit on the same value of x and y. Output of 0 or 0 is equal to 0. Output of 0 or 1 is equal to 1. Output of 1 or 1 is equal to 1. So the output is 110, which is equal to 6. Bitwise XOR operator. Bitwise XOR means to perform XOR operation bit by bit on the operands. For bitwise XOR, caret symbol is used. Let's understand XOR operation using this table. When both operands are false, then the output is false. When one operand is false and another operand is true, then the output is true. When both the operands are true, then the output is false. Here, if both the operands are same, then the output is false. When both operands are different, then the output is true. Here the variable x is equal to 4 and y is equal to 6. On performing bitwise XOR operation, x XOR y, the output is 2. Let's analyze how we got the output as 2. Now I am performing XOR operation bit by bit on the same value of x and y. Output of 0 XOR 0 is equal to 0. Output of 0 XOR 1 is equal to 1. Output of 1 XOR 1 is equal to 0. So the output is 0, 1, 0, which is equal to 2. Bitwise NOT operator. It returns one's complement of the number. For bitwise NOT, tilde symbol is used followed by an operand. For example, if x is equal to 5, then tilde x is equal to minus 6. Let's understand how we got the output tilde 6 is equal to minus 6. It is easy to evaluate the output. In this example, x is equal to 5. We just need to add 1 to x and change the sign. If it is positive number, change it to negative and vice versa. So the output tilde x is equal to minus 6. If x is equal to minus 5, then tilde x is equal to 4, because minus 5 plus 1 is equal to minus 4. And when sign is changed, the output becomes 4. Bitwise right shift. Shift the bits of the number towards right. Double greater than symbol is used for bitwise right shift. Here x is equal to 10, so x right shift 1 is equal to 5. Let's evaluate the output. Binary equivalent of 10 is equal to 1010. So x is equal to 1010. The command x right shift 1 will shift 1 bit towards right. So the rightmost bit is removed and a 0 is added at the left. So the result is 0101, which is equal to 5. Similarly, the command x right shift 2 will shift 2 bits towards right, adding 2 zeros at the left and truncating 2 bits from right. So the output is 0010, which is equal to 2. And the command x right shift 3 will shift 3 bits towards right, adding 3 zeros at the left and truncating 3 bits from right. So the output is 0001, which is equal to 1. Bitwise left shift. Shift the bits of the number towards the left. Double less than symbol is used for bitwise left shift. Here x is equal to 10, so x left shift 1 is equal to 20. Let's evaluate the output in detail. Binary equivalent of x is equal to 1010. The command x left shift 1 will shift 1 bit towards left. So a 0 is added at the right and the number of digits increases by 1 bit. So the result is 10100, which is equal to 20. Similarly, the command x left shift 2 will append 2 zeros at the right end. So the output is 101000, which is equal to 40. The command x left shift 3 will append 3 zeros at the right end. So the output is 101000, which is equal to 80. Open Python interactive shell. To find the binary equivalent of any number, use bin function. So bin of x is equal to 100, which is 4. Let's create two variables, x is equal to 4 and y is equal to 6. Performing bitwise AND operation on xy. The output is 4. Performing bitwise OR operation on xy. The output is 6. Performing bitwise XOR operation on xy. The output is 2. When x is equal to 5, then tilde x is equal to minus 6. Because 5 plus 1 is equal to 6, and when sign is changed, the output becomes minus 6. When x is equal to minus 5, then tilde x is equal to 4, because minus 5 plus 1 is equal to minus 4, and when sign is changed, the output becomes 4. Now let's do bitwise right shift. Assigning 10 to x. The binary equivalent is 1010. Here I am shifting 1 bit towards right. Output is 5. If we convert it to binary, output is 101. So 1 bit from right is removed. I am shifting 2 bits towards right. Output is 2. Binary output is 10. So 2 bits from right is removed. Shifting 3 bits towards right. Output is 1. Binary output is also 1. So 3 bits from right is removed. Let's do bitwise left shift. I am shifting 1 bit towards left. Output is 20. Binary output is 10100. So a 0 is appended at the end. Here I am shifting 2 bit towards left. Output is 40. Binary output is 101000. So 2 zeros are appended at the end. Here shifting 3 bits towards left, output is 80. Binary output is 1010000. So 3 zeros are appended at the end. Thanks for watching. If you like this video, please click on the like button, share the link to your friends, and don't forget to subscribe my channel so that you get the notification each time I publish a new video. See you in next video.